So what I have on the screen is your typical setup for an ice chart. Now the ice chart is just one step of a 4-step process you'll be learning about in the next lesson, but it's an important part of the process to make sure you've got it right. In some ways it's so simple that people will want to just skip right on past it and kind of jump through the hoops in their head. But the problem with that is that we're going to be building on the math that I'm showing you, and it will just get more and more complicated to the point that it is hard to do some parts of it in your head. So the way an ice chart is you've got your reaction, and then you have your I, which is your initial, C, which is your change, and then E is your equilibrium. So initially, this is usually most of the time in the problem. I've got the problem up here. Not a lot of words there, but it's a problem. Now, this initial is supposed to mean like the second or maybe the nanosecond that you mix the things together, but none of them have had time to run into each other yet. It's like you just barely were starting to mix them, and it's in that split second. That's initial. It means before anything happens. So that's going to be 0 because you don't have any product yet. You just started with reactants. You haven't made that guy yet. And then remember that your reactants are going to start at a high value and they're going to go down. So we will be losing some reactant, but we'll be making product. So that's why, like this number initial, it will always be going down because we're always making the product. And this number will always be going up because it's the product that's being made. Now, the way you determine how much is the molar ratios really do still matter here. And so those are both assumed 1s, and that one has a 2. So for every one of these, I have 2 of these. Now the idea is that you're just summing each column. So like that group, and that group. When you're summing it, that's what goes in the E section, the equilibrium. Because the equilibrium will be some point after you've lost something from your initial. You've got to have lost something, and some point after you've made some product. That's kind of what that's meaning right there. So the equilibrium is 0.0100, 0.0100, and I left off the minus x. Minus x, that's the whole point of this chart. So the chart actually helps you organize information, and it actually helps you make less mistakes, even if it doesn't feel that way. When you very first start getting into it, it feels like a lot of steps. You can do some in your head. Now, something to note about these is that just like in the K expression, like let's say I had some water over here and it was a liquid. Maybe I had some copper over here and it was a solid. I know that doesn't make sense, but I'm just saying, what if I had those in there? Remember, for the Ks, you don't include liquids or solids in there. So the K would actually still just be this, right? So the same is true for the ice charts. In ice charts, we don't include solids or liquids. All right, the other piece of information I want to let you know is where we're headed with this. So there will be, you know how like if you have 3 variables, you can always solve for one of them if you have at least 2 pieces of information. And that's the way this is. But the variables they look like more than they are. They're kind of connected. So here's our first variable, and it's K. So K is our equilibrium constant. This would either be given in the problem or in a chart. Like it'll be like, hey, go look in this chart. Or you're going to have to go and you're going to have to actually calculate something about it. So that's one piece of information. The next piece of information is actually this section right here. And you're like, wait, you're circling 3 things. Well, kind of. What I am doing is that I'm pointing out that if you know that 2x is 8, you know that x is 4. And if you know, or I guess I should have that x a lot smaller, right? 0.004. So that'd be 0.008. But if you know what this term is and you can solve for x, then you can also solve for this and for this. So even if you're only given one equilibrium value, there's always like some simple math to get to the other ones from your piece of information. So they're all grouped. So that region is something. And then the last region is actually up here, and that's your initial amounts. And again, this would be given in the problem most likely. And of course, you start off with 0 on the products. So again, the information's there, but you would have you'd have initial value from the problem, you'd have equilibrium value, and then you'd have to solve for K. Because these guys are actually going to be going into that formula, you can solve for K if you knew what those equilibrium values were. Another thing is that you might have the K value, and you might need the equilibrium, and then you're going to back calculate your initial values. Or, and this one is especially common, you have your initial, you have your K, and you have to solve for equilibrium amounts. And that's probably one of the most common, in all honesty, problems that you'd have to solve. But that is an ice chart, and that's how they work.